All right. 大家好，我回来了. That was me trying to say, hi, everyone, I'm back. I'm not sure how that went, but yes, I am back, and I'm so happy to be back here. I was here 4 years ago for RubyConf Taiwan, and I presented running Dreamcast or mruby on Dreamcast back then. And yeah, I'm back here with my Dreamcast. I don't want to lift it very high because it's all connected, but this was my spare Dreamcast at the time. I didn't use this one for the demo, but this time I brought this one. And also I've got my Nintendo Wii this time. So, and yes, I'm really happy to be back. And yes, this is about developing cross-platform mruby software for Dreamcast and Wii. Yeah. And first of all, I'd like to give you a bit of an announcement or maybe an apology. Well, I was hoping to run the entire presentation from my Wii, but this time I had many critical bugs that I couldn't really figure out. And I was trying till this week, but sometime this week I made a call. I probably shouldn't keep trying and just try to present from my my MacBook. So that's what I'm doing this time. And but because of this, the presentation is a lot nicer to read. Like the screen output is not from video game console, so I think it's a lot easier on the eye. And I'll still show you what I've got running on Wii at the end of this presentation. So it's not entirely just talking on about it with this presentation on my Mac. And I'd like to say that sometimes we need to try to be ambitious. If we never fail, we are probably not ambitious enough. So this time I tried and did not quite get what I wanted done, but I hope you'll still find this enjoyable and interesting. So here's a table of contents of my presentation. I will talk a little bit about myself, and I'll tell you a little bit about Dreamcast, Wii, and mruby. And then I'll tell you about the motivation. Why should you do? Why would I do this? Why should you do this? And something about the similarity between and differences between Dreamcast and Wii. And I'll tell you a little bit about CallistoOS and DevKit PPC and LibOGC. These are software development environments for Dreamcast and Wii, and also show you a bit of an overview of the development process and something about porting from Dreamcast to Wii. And I'll talk about the challenges I faced and changes that were required in C and Ruby code. And hopefully I will demonstrate my working software. And I'll conclude with summary and links and thanks. So about myself. I'm Yuji. I'm from Tokyo, Japan. I grew up in Tokyo. And you can find me, Yuji YOKOO, on ruby.social or same Yuji YOKOO on GitHub and Twitter and maybe some other places. And well, I have been living in Adelaide for decades, but last week I moved on the weekend. I started moving. I'm still in the middle of a move, but I started moving to Tokyo. I have packed up my Adelaide townhouse, and but I still don't have a permanent address in Tokyo. And I work at a place called CipherStash, which is a startup in Sydney. They work we work on database encryption technology, including searchable encrypted searchable encryption. So if you're interested in encryption technology that lets you look up the data please come and talk to me. And I'm not just spruiking this company for no reason. They were happy to be my speaker sponsor. As you could tell from my description, this topic has absolutely nothing to do with what we do at CipherStash, but they were still happy to be my speaker sponsor. So I'd like to thank them for that. And Sega Dreamcast. So, well, I really like Sega Dreamcast for many reasons, and I believe it's the best video game console, but that's my personal opinion. And it was a video game console released in 1998 and features Hitachi SH4 at 200 megahertz and 16 megabytes of main RAM. And the disk drive it comes with is called GD-ROM drive, which is like a higher density CD, which allows you to store about a gigabyte of data. And except for the late revision consoles, all Dreamcast units can run your own custom code by just writing a specially formatted CD. So no exploit needed. And because of that, a lot of indie commercial games are still released. And I actually purchased a game disc released this year, and it was called Driving Strikers, released in 2023 for Dreamcast. I think that's amazing. And Nintendo Wii, it was released in 2006, and it wasn't very powerful for its generation. But this was when Nintendo decided not to compete with other console brands in terms of processing power and graphic performance. But still, it features 729 megahertz per PC and a lot more RAM than Dreamcast. A whole generation difference makes even relatively conservative spec of Wii to be a lot more powerful than Dreamcast. And interestingly, by default it came with an SD card slot. And by default, we won't run your own code or unless it's properly released a game. It's not going to run it. But there are lots of easy exploits available. So years ago, I used one called Smash Stack, which exploited the Super Smash Bros. X discs and the program's vulnerability. And a few weeks ago, I used another exploit on another Wii called Letter Bomb, which basically requires a crafted message file to be saved in the SD card and be opened in Wii's message board. So exploits are really easy these days on Wii units. But because nobody, as far as I know, it's no one can produce a self-booting disk unless you're a proper manufacturer. Indie games on disks aren't very common with Wii. And a little bit about mruby. This is RubyConf Taiwan, so I expect lots of people to know a little bit about mruby at least, but it's another implementation of Ruby. So like if you don't know what implementation you're using, you're probably using CRuby, and there's other implementations like JRuby. And this one, mruby, is intended for embedded usage, and it does it's really good to integrate with your C programs. And mruby, since 2020, supports Dreamcast out of the box. This is the pull request that was merged back then. So it comes with a build config file for Dreamcast by default. And since October this year, mruby also comes with build config file for the Nintendo Wii. So if you want to build a Nintendo mruby library for Nintendo Wii, you should be able to do it with a single command, assuming you have the platform software already installed for developing Wii programs. So about the motivation, why did I do this? Like, why would I want to write cross-platform software between Dreamcast and Wii? So Wii was a very, very, very popular console. Dreamcast sold over 9 million units. That's impressive worldwide. We sold over 100 million units. That is, yeah, even more impressive. And so that means, and we being more recent, there probably are a lot more people with the Wii units just collecting dust at the place. So if I can get those people with those Wii units, I can get to develop something for Wii, and then also target Dreamcast as cross-platform target. Then I can get that many people to develop software for Dreamcast. That is my grand goal. I'd like to use Wii and cross-platform to increase the number of developers developing software for Dreamcast. And as I said, it's easily exploitable. And the most important reason, I had one at home. So Dreamcast and Wii, as I've shown, there are lots of differences, but also similarities. So architectures are different, and they come from different generations, and the software stack is different. But both have free open source SDK, and they both use GCC, and they both allow running your own code quite easily. So that makes them a pretty good target for cross-platform development. So Callisto OS is for Dreamcast. It's the development environment, or sometimes called pseudo OS. It's also known as Chaos, and it comes with provides a C API and GCC, and does a lot of things like file system control IO graphics and BSD licensed, and it has a long history. And DevKit PPC and libogc. DevKit PPC is a tool chain for PowerPC, providing GCC and linker, etc. And libogc is the low-level library for Wii and GameCube. So a lot of it's not really very feature-rich, but a lot of other libraries are built on top of them. And libogc and DevKit PPC were designed to be used together. But if you're doing, say, commercial software development using libogc and DevKit PPC, you might want to carefully check the license because components of these have different licenses. And so here's the development process overview. To get started with development, you need to write some C code. Here, you don't really have to read this, but this is the main function of the C, which does a bit of platform-related initialization things. And this part initializes mruby and defines a class and attaches function, or defines a module and attaches functions to it. And this part is where the program is loaded. Here, program is defined elsewhere. It's the bytecode of your program, and starts mruby. And when it's done, it exits. So that's the loader part of the C code. And once you have the loader, you might want to write the actual Ruby code. This is a top level Ruby file, and I'm not going to go into any more details, but this is really just plain Ruby code, which utilizes the module provided in the defined in the initial part of the C code. And as you write Ruby code, you might need to write more C code because your Ruby program might need to access the video RAM, or maybe you want to check the controller state, and you might. This is an example for waiting for VSync. VSync is a video-related vertical sync signal, which you can use to keep your game running at a constant pace. So if you're running in NTSC, you probably get 60 hertz. If you're using PAL, you probably get 50 times. So this, if you, this is a C function, but it returns an mruby value, which is which is something you can return from this C function back to mruby. But in this case, it's returning a nil. And once you write the mruby code, you can compile it with mrbc and produce the bytecode. This is what the bytecode looks like. It's in C array representation of 8-bit numbers, so you don't need to read this, but this is named program, which was loaded earlier in the main function. This is where program was defined. And as the bytecode is in C array format, you can put them together with C code, compile to produce object files, and that object file could be linked against the platform library and mruby VM library, and that produces executable in ELF format. And usually after this, even though ELF is executable, you to put on game console, you need to do another step, which is building the image. The tools usually come with the platform SDK. So that produces a disk image. And with the case of Dreamcast, you can just write it on a CDR. If you don't know what CDRs are, they're writable CDs. And if you don't know what CDs are, I hope you do know what CDs are. But in my case, I have a modified Dreamcast that replaces the optical drive with an SD card loader, which emulates the optical drive. So in both cases, I'm using an SD card. And when porting from Dreamcast to Wii, the goal is to use the same Ruby code for both platforms, hopefully exactly the same. And that can be done by implementing the same Ruby API between Dreamcast and Wii. And that means the underlying C code will have to be quite different, because platform libraries provide different functions, different data types, and everything's different. But if the Ruby API is the same code, it should be able to run. And also, it's important to stick to the common set of features. For example, screen resolutions. Video game consoles can come with many different video resolutions, but you need to pick one that's common amongst different consoles. Otherwise, you have a lot of hard time trying to figure out how many pixels should be squashed into how many pixels on each screen. And also sticking to common interface. So when you think about Wii, you might think of the motion sensor control, but I'm sticking to a GameCube controller because that's a lot closer to the Dreamcast controller. And here are some of the challenges I faced. And particularly for Dreamcast, many tools assume you have a Windows machine and an Intel processor. So it's not impossible to run those programs on other environments like Apple Silicon, but when you have a 32-bit Windows Intel 32-bit Intel program expecting Windows and try to run it on an M1 MacBook, it's not straightforward. It's a lot of pain. And also, because of the move I mentioned earlier from Adelaide to Tokyo, I packed up all my Intel machines. So that caused the situation really difficult. And lots of broken links because a lot of tools were released like 2003, 2005, and a lot of links were broken. But fortunately, archive.org had a lot of those things available. So yeah, I made a small donation to them following this because I was so grateful. And also, a lot of tools are distributed binary only with no source. So that means if something goes wrong, it's hard to tell what might be going wrong. And also, a lot of binary only tools are unsigned or old binaries. And if it's unsigned, you could just say, all right, just run it anyway and run it at your own risk. But if it's too old, you might not be able to run it at all. And debugging is hard. And I saw a lot of this green screen that I had no idea. It happened somehow, and I got around it. Then it happened again and got around it. It was really elusive. I mean, every bug is mysterious until you figure it out. Until you figure it out, it's every bug is mysterious, of course. But this one in particular was very elusive, and I still haven't figured out. And that's one of the reasons. This is one of the reasons why I decided not to go ahead with presenting on Wii. And also, again, debugging is hard, especially when you're running it on the console themselves. You have very little visibility of what is going on the console, what's gone wrong. So debugging is hard, and setting up proper debugging environment is also difficult. So I've tried to set up some debugging environments a few times and failed each time. And here are some of the changes that happened, that was required in C. So these are just header changes and some platform related changes, but none of it is really important. But what's important is, well, actually the diff isn't really useful, but what's important is a lot of changes happened in C, and there's a lot more. And this one was something I found a little bit interesting. The top red part is the using chaos bfont drawstring function, and the bottom green part is using interestingly printf provided by the Wii libogc. So because of this, the Dreamcast side has got more control over exactly where the text is going to be at pixel level, but with printf approach, the location is specified by column and row. So these are this is not the location using printf is not going to be exactly the same location. And another interesting part, this is 16-bit RGB versus Y1CB, Y2CR. On Dreamcast, on VRAM, each pixel was packed in 16-bit integers or 16-bit data, 5 bits for red, 6 bits for green, and 5 bits for blue. And that was a single pixel. But on Wii, the pixels were encoded in Y1CB, Y2CR, which is sort of based on the old television signal. So television used to be black and white, and color signal was introduced later. So what happened there was black and white signal was kept intact, and color signals were added later. And black and Y represented the black and white signal, and CR and CB were color signals relative to the Y signal. And also on top of that, as you can see, there's R1, G1, B1, R2, G2, B2 in the arguments. So they're taking RGB values. This is taking RGB values twice, which means 2 pixels of 16 bits each are packed into 32 bits. So this was really tricky. I have no idea what this code, exactly how this code works. I copy pasted it from elsewhere, but it seems to work okay. So I went ahead with it. But this is an interesting part of the Wii platform. So after all these changes, what you might be wondering, what changed in Ruby? Well, not a lot. So this is the first page. I removed put S and P because those are used in Dreamcast emulators for printing to the console, and I do not have that in Wii emulators or Wii. And I changed the class name in the first green line. In the second green line, instead of using the P method, I changed it to um, a method I implemented called print message that prints to the screen. And the second page, as I said, 2 pixels had to be packed together. I did a simple workaround of simply halving the horizontal resolution, and instead of treating it as a 640 times 480 resolution, I changed it to 320 times 480, and that meant up the top the value has been halved, and also in the middle the value x times 20 became x times 10. That's half too. And also the interesting one at the bottom was this was simple debug. The top red part was not causing a problem with Dreamcast, but was causing a problem with Wii, so I had to debug that. So that really it has nothing to do with the platform changes. That was just me, my bug, and that's it. That's all I had to change on Ruby side. So now here comes demo time. Will it work? Of course. Well, I'm not so confident now. So let's see. Could I? Okay. Seems to be okay. Oh, wait. Okay. So here's my video capture. And this is a Dreamcast version I demonstrated 4 years ago. So this is not what I did this time, but just to show you the baseline of what the original game looked like. Oh yeah, this is the SD card loader, the boot menu of SD card loader. Now I'm booting the actual game. So here it is, and the game works like this on Dreamcast. Thank you. Well, so this is a baseline. This is what I had 4 years ago. So I scored 1 point for deleting one line. So let me turn this off, and now plug in to the Wii unit. So now please remember what it looked like. And this is I replaced the boot screen on Wii so that I can go straight into my homebrew applications selection. And here we go. This is the moment of truth. If this looks like what you saw on Dreamcast, that's success. There we go. Oh crap. Let me just play till I can erase one line. because there you go. Oh, I scored 100 points. Thank you. Yeah. So the that was a demo, and the game worked fine on Wii as well. So oops. So here's the to do in this project. I would like to. There are a few things about string printing earlier, and I would like to unify the API, and also horizontal resolution currently is reduced to 320, so I'm going to change it to 640, and also this time, unfortunately, I did not have the presenter working on Wii. I would like to get that going on Wii in the future, and also yeah, running the exact same code onto platform on the presenter. And also, I'd like to be able to have the single source and generate Wii binary and Dreamcast binary from by changing the parameters. And in summary, cross-platform kind of works. And Ruby code did not have to change that much because the C changes absorb the platform differences. And debugging is hard. And also, just my personal note is moving internationally and presenting within the same week is just chaos. If anyone's thinking about that, don't do it. And I'd like to thank mruby developers, CallistoOS developers, and DevKit Pro, and Simulant Game Engine Discord server, where awesome Dreamcast developers gather. And here are the links: mruby, CallistoOS, DevKit Pro, and WeBrew has a lot of useful information if you want to work on Wii. And the bottom one is my demo game source code. And that's the Wii version, that is, not the Dreamcast version. And thank you very much for listening.
Okay. Thank you, Yuji YOKOO. Thank you for your informative sharing. Now we are going to have Q&A session. Please feel free to ask any question and raise your hand. Have anyone have some questions? Okay.
I think thanks for your presentation. I'm just wondering if there's any future plan to port mruby to some modern console like Switch or 3DS or etc. Yeah.
So the question was, do I have plans to port mruby to more modern game systems? Was that it? Yeah. I currently don't. But at the same time, though, mruby has been people have ported mruby to Switch, and I believe there was a Ruby Kaigi talk a few years ago that was on that topic. So, and I guess it would be interesting to do that, but I'm not saying I'm never going to do it, but I currently don't have any plans for that.
Okay. Thank you. And have anyone have questions? Okay.
Hi. I'm just curious about that. If you need to debug, every time you need to run a new CDR and then check out what the problem is, or is there any way to debug? Because if you want to run the code, you need to run on the Wii or Dreamcast.
Sorry, I couldn't really catch that. Can you?
I mean, talking about the debug, if I want to know what in my imagine, if I want to run the code, I need to burn a CDR to put in Dreamcast or Wii, and then I can know the problem is.
You need to run. Sorry, I'm terrible at hearing in this kind of environment. I'm sorry. Could you repeat?
Okay, just I just curious about how to debug your code. How you debug the code. Debugging. Debugging. If you writing code and you find you want to check out the code is working or not.
I'm terribly sorry. I'm terrible at hearing in this kind of environment. But anyway, yes, yeah. How I debug? Yes, because for Dreamcast, if I use an emulator, and one of the emulators has got a console output that lets me print to the terminal window. So that lets me do a lot of printf debugging. And for Wii, though, I'm not aware of any emulator that would do it. So generally, I try to print things onto the screen directly by and do printf debugging. But as far as I know, there are debugging tools. Like for some emulators have network remote debugging supported, and that's supposed to be available, like supposed to work, but I've never got it working, so I haven't put in enough. I haven't investigated that option enough, but yeah, with the unit itself, it's very hard to know what's going on. So that's why I kept on saying debugging is hard. But there are some devices you could attach to Wii and record some data, as far as I know. So that's possibly something I could use. But in short, how do I debug with difficulty?
Okay, this meeting will end in 3 minutes. So that will be the last 1 or 2 questions. Have anyone have any questions? Or speaker have anything to share with our attendees?
Thank you for being here. And I'm not sure who finds this topic interesting, but I'm really glad there are so many people here. And thank you very much for being here. It means a lot to me.
Okay. Okay, this meeting is over. Thank you. Let's take a short break right now. The next session will start at 2:25. Thank you.